Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 6, Lesson 7, Word Problems Involving Two-Step Equations, Day 2. That's right, this is a follow-up to Day 1. So if you haven't seen our Day 1 lesson, or you haven't gone through it with a teacher, your classroom teacher, you really want to make sure you do that before you jump into these problems. To put it mildly, today what we're going to be doing is we're going to be modeling a variety of different scenarios that lend themselves well to two-step equations and two-step algebraic expressions. There are going to be occasions today where I'm going to want to use a calculator, so I've got mine kind of ready to go whenever I need to bring it out. You may want to have yours ready to go as well. Maybe you even had it ready in the last lesson where we didn't particularly need it. Anyhow, either way, let's jump right into it with the first problem that we're going to model using a two-step equation. Here we go. All right. Many geometric situations can be modeled using two-step equations, and we're going to take a look at a few of them today. Let's take a look at exercise number 1. A rectangle has a length of 12 feet and an unknown width, represented by the variable w. Letter A says if the perimeter of the rectangle is 38 feet, find the width without using algebra. Show how you found your answer. All right. Great. So my contention is, without having any algebra at all, if I give you this picture, you know the length is 12 feet, you don't know what the width is, but I've told you that the perimeter is 38 feet, then you probably can figure out what the width is. So pause the video now and see if you can figure it out. All right. Well, keep in mind, right, the perimeter is the sum of this, and this, right? Where obviously if that's 12 feet, then this is also 12 feet. Let me just write that in so that we've got it. And as well, if this is the variable w, this is the variable w, all right? And we'll use that eventually to kind of model it algebraically, but what I would be doing without any algebra at all is I'd say, well, all right, in total, this has all got to add up to 38. Well, I know I've got 12 and 12, right? I've got 2 times 12. So 24 feet is already taken up by that, right? So I might then take my 38 and subtract off 24, right? And I would get 14 feet. Now keep in mind, right, that 14 feet has to be dedicated to both of these two, right? Both of those two widths. So then I would probably take my 14 feet, I would divide it by 2, and I'd find that my width must be 7 feet. And again, it's quite easy to check, right? Because I could do then 7 plus 12 plus 12, see if it's equal to 38, which it would be, all right? So, it's actually relatively easy to do this problem without using algebra. But now let's model the problem using algebra and see how the solution really mimics this solution as well, all right? So let's kind of take a look at that in letter B. All right, letter B. Now let's solve this problem algebraically. That is by setting up and solving an equation. Set up an equation using W and solve it. Verify your answer is the same as in A. That's not going to be very hard. Our answer in A is 7 feet, but we would want to make sure if we don't get 7 for this that we, I say that we go back and rethink one of the two problems. Anyway, so here we go. How are we going to do this algebraically? Well, again, we've got the same diagram down here. It only shows up once on your page, but I'm going to put the W, the 12, and the 12 there, right? So what equation really models this? Well, the equation really would be if I've got W plus W, right, those two widths, plus 12 plus 12, those 4 lengths have to add up to the perimeter of 38, right? And this really does model the scenario that's going on. Now, of course, to solve this, we might do a little bit of just combining of like terms on this side, right? So that's not really part of the solution. It's just, getting us ready for our two-step technique. And now we have this. Now, keep in mind, what are we going to do? We're going to subtract 24 from both sides. Minus 24 minus 24. And we're going to find that twice the width is equal to 14. Now, before we finish solving this, I want you to keep in mind that up here, right, first thing I did was I added the two 12s together and I got 24. Then I took my 38 and I subtracted my 24 and I got 14. That is exactly what's going on right here, right? When I subtract the 24 from the 38, and now I have my two widths are equal to 14, which means if I divide both sides by 2, I find a single width is equal to 7. And even that division by 2, right, was exactly what I was doing right here. All right, so the algebraic process, especially the process of throwing equations around on the board, no, just kidding, especially the process of just simply step-by-step solving the equation really mimics exactly what we did when we kind of solved it without algebra. Which then begs the question, why would I do it with algebra? Well, there are certain situations where it's much harder to kind of do it just by like kind of reasoning through it with just normal numbers. So let's get into some of those in the next problem. All right, another geometric problem. Let's take a look at exercise number 2. A square and a rectangle are shown below. The side lengths of the square are unknown and represented by the variable s. The rectangle has a width of 10 inches and a length that is 5 inches more than the side length of the square. The area of the rectangle is 210 square inches. Letter A asks us to write an expression for the length of the rectangle in terms of s and label it on the diagram. All right, that's easy enough. Why don't you pause the video, make sure that you've read through the problem carefully enough that you can then answer letter A, and then make sure to also label on the diagram that answer to letter A. Well, what do we know about the length of the rectangle? Right, it says the rectangle has a width of 10 inches and a length that is 5 inches more than the side length of the square. Well, the side length of the square is s. 5 inches more than that would be s plus 5. Just got to watch out that my s's and my 5's don't look identical. All right, but that's going to be this length. All right, now letter B. Set up and solve an equation to find the value of s based on the area of the rectangle, right? So really quick, let's go up here. What was the area? The area was 210 square centimeters. Sorry, hold on. 210 square inches. Square centimeters wouldn't have made any sense. All right, so the area is 210 square inches. We want to set up an equation, right, involving this diagram. The square is kind of irrelevant at this point that'll allow us to solve for s. Pause the video now and see if you can do that. All right, well, the area of any rectangle is its width times its length, right? So if I were just to write down an expression for the area, it would be 10 times s plus 5, right? That is how we find the area of a rectangle. We take one of its dimensions and we multiply it by its other dimension. Length times width, width times length doesn't really matter. But we know that this product must be equal to the area of the rectangle. We know it must be 210. All right, and there's the equation that models the information that they gave us. Now we still want to solve it, and we've got two choices. We can either distribute the 10 using the distributive property and then go ahead and solve it from there. Or we can say, well, I had 5 added to s, and then I multiplied by 10, so I can undo that by dividing both sides by 10 and then subtracting 5. And that's where I'm going to go, because the structure of the problem, it just calls out for me to do it that way. Plus, I like dividing by 10, right? Because all I have to do to divide 210 by 10 is move that decimal place 1 unit to the left, and that'll give me 21, right? Now this is easy enough to solve. I'll just kind of try to sneak it in right here. I'm going to subtract 5 from both sides. That will cancel, and it looks like my side length is 16 inches. All right, easy enough, right? Now, letter C, simple enough. What is the area of the square? Why don't you go ahead and do that for yourself? That should be pretty easy, and then we'll move on to the next problem. Well, the side length on the square is 16 inches, right? It's 16 inches by 16 inches. The area of a square, right, is going to be equal, let me give a little more space there. The area of a square is going to be its side length times side length, or side length squared. That's going to be 16 times 16, which you can do on your calculator or you can do it longhand. Either way, it's going to be 256 square inches. All right, we won't go through the long multiplication because you could clearly do it on your calculator if you wanted to and should also be able to do that. All right, let's model some more problems using algebra. Here we go. All right, word problems that involve rates, right? How fast something is changing compared to something else, and some initial amount often can be modeled using two-step equations. Let's take a look at an example of that in exercise 3. These are very important situations that can be modeled with two-step equations. Here we go. Kamala is saving her allowance. She earns $25 per week for doing chores around the house. She starts with $40 in savings. Letter A asks us, how much will Kamala have saved after the following amounts of time? Show your calculations. So we want to know how much Kamala has saved after 3 weeks and after 10 weeks, all right? Let's do one of them together and then have you do the other one on your own. This is pretty easy, right? So if I just ask you, how much did she save after 3 weeks? Well, we were told that she earns $25 per week, so I might do something like 25 times 3, right? Of course, that would give me $75. But then I can't forget to add in that initial $40 of savings that she has. And so after 3 weeks, she's saved $115. All right, again, not difficult. Why don't you go ahead and do it for 10 weeks? Now, one of the really important parts of this problem, right, and one of the reasons that I write it so that you've got this letter A, no algebra involved or anything like that, is I want to make sure you see the pattern, right? So for 3 weeks, we did 25 times 3, right? And then we added 40 on. For 10 weeks, we're going to do 25 times 10, right? And we're also going to add that 40. Of course, 25 times 10 is 250, plus 40 gives me $290. All right, so simple. Now let's take a look at letter B, where we make our algebraic jump. Let n be the number of weeks that Kamala has been saving. Write an equation that gives the amount of money she has saved, including the original $40. All right, well, based on what's going on here, I'd like you to try to write an expression. It's not an equation. There's no equal sign here. I just want an expression that if you told me the number of weeks she had been saving, n, I could then calculate using that expression how much she's saved, not shaved, saved. Go ahead and pause the video now and see what you can write down. Well, when n was equal to 3, we did 25 times n plus 40. When n was equal to 10, we did 25 times n plus 40. So clearly, right, the answer here is 25 times the number of weeks plus 40. Right? If I take $25 per week, I multiply it by the number of weeks she's been saving, and then I add in that original $40 she saved, then I know how much she saved. Now, if you wrote down 40 plus 25n, that's completely okay, right? That's the idea of, I started with the $40, and now I'm going to add 25 times the number of weeks. But those two are algebraically equivalent because, again, 40 plus 25n plus 40 are the same due to the commutative property of addition. All right, now let's take a look at letter C. Here we go. After a certain number of weeks, Kamala has saved the following amounts of money. Set up equations using your expression from B and solve them to find out how many weeks. All right, well, let's do the first one together, have you do the second one on your own. Right, we know right now that the expression 25n plus 40 will tell us how much she's saved up after a certain number of weeks. Well, if this is the savings that she has, then to figure out the number of weeks, we would just have 25n plus 40 equals 425. All right. Now this is a fairly simple two-step equation to solve, right? I'm just going to subtract 40 from both sides. All right. And again, this is where a calculator can become handy just to make sure you don't make any kind of easy mistakes. So I maybe will take my own advice right now. 425 minus 40 gives us 385. All right, divide both sides by 25. All right, and In fact, what's nice here is I can literally just hit divided by 25 equals 15.4. All right. Now, I would like to just, for a moment, point out the fact that this is somewhat of an unrealistic answer, which actually means that I did a poor job designing at least this part of the problem. All right. You know, she's getting paid this on a weekly basis, so we kind of expect this answer to come out as a whole number. 16 weeks, 14 weeks, 22 weeks, whatever. 15.4 weeks is a bit unrealistic, but we're going to stick with it for right now. You're going to have a more realistic answer when you do the second part of the problem. So figure out how many weeks it's going to take her to save up $1,340. Go ahead now. All right, let's do it. So again, same idea, right? We're going to take this expression that predicts how much she's saving, and we're going to set it equal to 1,340. All right. We're now going to solve this with exactly the same steps we did before. Subtract 40 from both sides. This time I don't think I need a calculator to figure out the first part. That's just going to be 1,300. But now when I divide both sides by 25, this is when I definitely would rather have my calculator because I don't really want to do that. So let's do 1,300 divided by 25. And that gets me 52. All right. By the way, just a quick question for the trivia buffs. What's important about 52 weeks? It's the number of weeks in a year. So it would take her a whole year to save up $1,340. Full year. All right. Let me bring this back down here. Let's keep doing some modeling. Take a look at another problem involving rates. Exercise number 4. A pool starts with 350 gallons of water in it. It is then filled with water at a rate of 85 gallons per minute. In how many minutes will it contain 16,670 gallons of water? Let m be the number of minutes. Set up and solve an equation to find m. All right, so this one, I don't really walk you through all that much. You know, you have to immediately kind of go into the modeling and the solving. Why don't you pause the video now and try to model this problem mathematically and find the number of minutes it's going to take to get up to that amount of water. All right, well, the first thing you should ask yourself is, how could you figure out, if I gave you a certain number of minutes, if I said, how much water was in there after 5 minutes? You know, what would you do? Well, hopefully you'd take the 85 gallons per minute, that rate, right? And this is very important, right? This rate that we're dealing with, right? 85 gallons per minute. You would multiply that by 5 minutes and figure out, well, whatever that is. And then you'd add it to the 350 gallons that was already in there, right? So you'll take the amount of time, right? You'll multiply it by the rate. You'll add on the 350 gallons, and that will tell you how much water is actually in the pool. Well, we can write that down as an expression, right? That would be 85 times m, right? 85 is the rate times the time, plus then the 350 gallons. That expression, not equation, that expression will tell us how much water is in the pool after m minutes. But if I want to know how much water was in the pool, or sorry, how many minutes it took to get 16,670, then I will simply write this down. And now let's go ahead and solve it, right? So, some bigger numbers here, but still relatively easy, right? So subtract off 350 from both sides. Again, if this is something that you feel comfortable doing without a calculator, great. That's pretty easy. Now, the division by 85, that's where I'm going to want my calculator at least. So let me bring that thing back up, clear out our previous calculation. We're going to have 16,320 divided by 85. And it looks like it will take 192 minutes. All right. Now, rate problems, again, are exceptionally important, especially rate problems that involve some initial amount, right? Some initial amount. Think about it. Last problem, right? The rate was $25 per week, right? That something per something, plus an initial amount that she had saved, which was $40. This has exactly the same structure, right? 85 gallons per minute, right? That's the thing that's multiplying our variable, plus the original amount that we started with, 350 gallons. Very often, when we've got some original amount and then some rate, right, that lends itself to two-step expressions and also two-step equations. So, let's keep doing this kind of modeling. Here we go. Sometimes we have to be a little careful because the rate problems can actually involve subtraction. Those are the trickiest things, and you'll know it if there's some kind of quantity that's decreasing, it's going down. So let's take a look at one of those as our last exercise in this lesson. Exercise number 5. Kevin starts with 80 ride tickets at the fair. For each ride Kevin goes on, he must use 3 tickets. How many rides has he gone on when he has 38 tickets remaining? Let R be the number of rides, set up and solve an equation for R. All right, so again, before we even set up the equation, just for a second, let's say that Kevin went on 4 rides. Right? Let's just say that he went on 4 rides. That's not the answer to this problem. All right, but let's say he went on 4 rides. How would you figure out the number of tickets he's got left? Well, you would probably do something like this. You'd probably say, well, you know, I'll do 3 times 4, right? He's going to use 3 tickets per ride. For each ride, he's going to use 3 tickets. So, you know, he will have used 12 tickets up. And then you'd do 80 minus 12, and you'd figure out 68 left, right? That's what you'd do. And notice the amount that he's got left is going down as R goes up. As the number of rides he takes goes up, then the number of tickets he has left goes down. Now, how do I calculate the number of tickets he's got left? Well, what did I do here? I had 3 times the number of rides. That was this, the 12. And then I subtracted that from 80. If I want to do that with the R just being generic, right, not being specifically 4 rides, then I wouldn't do 80 minus 3 times 4. I would do 80 minus 3 times R, right? So 80 times 3 minus R is going to tell me how many tickets Kevin has left. Now, I'm going to set that equal to 38. Okay. Now, these equations are always a little bit more challenging to solve, although we certainly have solved some like this. I'd like you to pause the video, work through this, and try to figure out how many rides Kevin took so that he only has 38 tickets remaining. All right, well, simple enough. One thing I'm going to do is I'm going to rewrite this as negative 3R plus 80 and set that equal to 38. I'm now going to subtract 80 from both sides. Again, we need to be careful here because we've got a smaller number subtracting a larger number, so we're going to get a negative result. Now, if you're kind of like, well, what result will I get? You could do that on your calculator. You just literally do 38 minus 80, and you're going to get a negative 42, right? Furthermore, if you're a little bit confused about dividing negatives by negatives, right, you could then say, well, I'm going to divide that negative 42 by negative 3, and I find that the number of rides Kevin took was 14. All right, that is of course a little bit more challenging because what's going on is we've got something decreasing based on a rate, right? You might even say that the rate is negative. Negative 3 tickets per ride, right? Because the number of tickets that Kevin has is going down. All right, let's wrap this thing up. Today what we saw is we saw more problems that lend themselves to two-step approaches. Some of those were geometric, based on either perimeter or area of commonly known figures. Others, though, involved rates and initial values. Maybe we saw an initial value that someone had saved and then a particular savings per week, right? These kind of problems happen all the time in mathematics, economics, physics, chemistry, all sorts of different areas. Being able to set up simple two-step equations to solve them is really key. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.